We can see a diagram of a cylinder with radius r and height h. We're told that it's an open cylinder. This means that this cylinder has no top. It's constructed from 105 pi centimeters squared of material. We want to find the maximum possible volume of the cylinder. Since it has no top, the surface area of the material is made up from the circular bottom and the curved surface of the side. The surface area therefore is pi r squared for the bottom and 2 pi r h for the curved surface of the side. We know this is 105 pi, so 105 pi is equal to pi r squared plus 2 pi rh. We can cancel pi throughout, giving us 105 is equal to r squared plus 2rh. So 105 take away r squared is 2rh, and then h would be equal to 105 minus r squared divided by 2r. We now need an expression for the volume. The volume is pi r squared h. We have this expression for h, so we get pi r squared times 105 minus r squared over 2r. And we can simplify this, cancel the r's, bring the 2 on the bottom outside, and multiply the r into the bracket. So we get 105r minus r cubed. We want to maximize v, so therefore we're going to find dv dr and put it equal to 0. dv dr is going to be pi over 2 into 105 take away 3r squared. We need this to be equal to 0, and of course the pi by 2 is just a constant, so we can just take 105 minus 3r squared and put that equal to 0. This gives us that 3r squared must be equal to 105, so r squared is 35, and r must be equal to the square root of 35. To find the maximum value of the volume, we substitute this into the expression for the volume. So pi over 2 times 105 times the square root of 35, take away the square root of 35 cubed. And this gives us 651 centimeters cubed, correct to 3 significant figures.